Let's go through how to count atoms worksheet. I'm going to take you through some examples on the front, and then I'd like you to upload the completed questions on the second page as an assessment and a completion mark. So whenever you just see a single element symbol, which always is either just a capital letter, or if there's two letters involved, the second letter will always be a lowercase letter. So that indicates that that is one symbol. This symbol is for sodium. So we would say in this scenario, we have one atom of sodium. So if you can go ahead and write that. Now, whenever we have a molecule, you will have a smaller subscript, which is always written in the lower right corner beside the element symbol. And if there's more than one atom in that particular molecule, you will state how many there are. So in this case, this indicates that you have two atoms of hydrogen. Now, when we get into more complex type compounds, in this case, just to refresh your memory, this is magnesium. This is a polyatomic group called phosphate. Magnesium only has one valence option, and it is a 2. Phosphate is a -3. When they crisscrossed, the formula is Mg3 bracket PO4 bracket 2. We do not have to indicate a Roman numeral because magnesium only has one valence option. So this happens to be magnesium phosphate. Okay, and it's polyatomic and it's an ionic compound. Now, when we take a look at how many of each atom there are to make up this compound here, we take a look at the subscript that is directly beside the element symbol. So in this case, there happens to be 3 magnesiums. It's not inside of a bracket, so we're just going to write 3. Whenever we see a compound and there's a bracket and there is no number directly beside the element symbol, you assume that there is a 1. So inside the bracket right now, there is 1 phosphorus. But because we have a subscript outside of the bracket, that number applies to everything in the bracket. So you must multiply the number of atoms inside the bracket by that value. So 1 times 2, so there are 2 phosphorus atoms to make that compound. Inside the bracket, for oxygen, there is a 4, but we must apply this 2. So we have 8 atoms of oxygen in that compound. Sometimes we have big numbers out front. These are not called subscripts, but they are called coefficients. These numbers can change in order to help us balance equations later on. The numbers that must always remain the same when we are making our compounds are these subscripts. So we're not allowed to change those, but moving forward, just so you know, coefficients can be changed. So this big 3 would apply to everything in a compound. In this case, we just happen to have a single atom of carbon. So we would say that we have 3 atoms of carbon when we have a coefficient of 3 written out front. So let's take a look at these 3 examples. So in this case, when you have a big 2 out front, that means that you have 2 molecules of water. So I'd want you to draw 2 molecules of water. So in that case, if I was to do that, this is what it would look like. And water is a bent molecule, or we call it a V-shaped molecule. And the 2 lone pairs actually sit just on top of the hydrogen. We get into shapes more so in grade 12. But in this case, if you were to count up 2 molecules of water, you would have 1, 2, 3, 4 atoms of hydrogen, and you would have 2 atoms of oxygen. What we can do is whenever we have a coefficient, we can apply that by multiplying all of the subscripts within the molecule by that value. So in this case, instead of having to draw, we can just say that we have 4 hydrogens and we have 2 oxygen atoms. In this case, CuSO4, what is that compound? Let's just refresh our memory. SO4 is a polyatomic group, and I'm just going to temporarily put brackets there. Copper can be a 1 or a 2. So copper 1 or copper 2. Sulfate is always a -2 when I look on my polyatomic sheet. And when I notice in the crisscross, because the brackets have been dropped, they had to have used a 2, okay, in order for those subscripts to reduce to the lowest common factor. This is called copper 2 sulfate. Now, whenever we have a big coefficient of 3 out front, that means that we have 3 molecules of copper 2 sulfate. So again, what we're going to do is we're going to apply that 3 to every subscript. So I'll just rewrite that out so you can see that a little bit better. When there is no number beside the Cu symbol, you assume that there is a 1 there. Same with sulfur, we assume that there is a 1. That 4 only applies to the oxygen, not the sulfur. So if we were to use that coefficient and apply it to everything in the compound, that means that you would have 3 copper atoms, you would have 3 sulfur atoms, and you would have 12 oxygen. So if I needed to make 3 molecules of copper 2 sulfate, this is how many of each you would have to pull out from a molecule kit. The last one would be sort of the trickiest one that you would get, where you not only have a coefficient out front, but you also have brackets with subscripts. Really important that we can help figure out how many of each atom we have. So just to mention, lead has more than one valence option. Lead can be a 2 or a 4, and nitrate is a -1. Remember, the first part of the compound is always your cation. The second part is always the anion. This is polyatomic compound, and that is because there's more than 2. If there was only 2 atoms, it would be a binary compound. Poly means more than 2. So here, this would be, based on the crisscrossing, lead 2 nitrate. This coefficient tells me that we have 4 units of lead 2 nitrate, or 4 molecules. We apply that 4 to everything. Now remember that when there is no number beside the lead, we assume that there is a 1. Inside the bracket, we're going to assume that there is 1 nitrogen as well. We have not yet got to this part. So because the lead is not inside the bracket, we can simply say, well, 4 times the 1, we have 4 lead. Now, what I do is I look at each part in the compound within the bracket. There's 1 nitrogen. Now I must apply the little subscript. So we must multiply that by 2. And we must also apply the coefficient times 4. So I break it down step by step. 1 times 2 times 4 gives you 8 atoms of nitrogen. Let's take a look at oxygen. There are 3 atoms of oxygen inside the bracket. There is a 2 outside of the bracket, so we multiply that by 2, and then we must also multiply by the coefficient out front. So here you have 3 times 2 is 6, times the 4, which gives you 24 atoms of oxygen. Okay, so those ones are a little bit tricky because you have to not only multiply by the number outside the bracket with whatever is inside the bracket and the coefficient. What I would like you to do is to go ahead and complete the second sheet. And what you'll do is you'll take a look at the compound. You'll list the type of atom. So I'd like you to name each atom. So in this particular case, you would say, okay, Na, that is 1 element. So that is sodium. When I come to the next capital, that is the next element. So that would be carbon. Then I come to the next capital letter, so that means it's a new atom. So that is oxygen. Then I'd like you to tell me, okay, in this particular compound, there are 2 sodium atoms. There's 1 carbon, 3 oxygens. Add those up, and you have 6 atoms in total. If you see a compound where there are 2 elements that are the same listed, you just list it once, Okay, so there would just be hydrogen, there would be one line allocated for hydrogen, and in this case, you would add those together. Okay, all the best, and we'll see how you do once I assess your learning.